KCF Technologies presents Industrial Transformation, Stories of Failure and Success from the front lines of American manufacturing.
Welcome to the Industrial Transformation Podcast. We will be discussing stories of failure and success from the front lines of American manufacturing. I'm Marty Wolf, and I'm with the host of the Industrial Transformation Podcast, Jeremy Frank. Jeremy is the CEO of KCF Technologies. Hello, Jeremy. Good morning.
Good morning, Marty.
So, Jeremy, we connected a few months ago when you were a guest on my podcast. During that conversation, we talked about the changes that are occurring in manufacturing and how some companies are adjusting and some are not adjusting to current and predicted market conditions. Give me some thoughts on that.
Absolutely. And just thanks again, Marty, for having me on your show and what kicked off this industrial transformation series of interviews. I think my company is very much focused on industrial transformation. And we believe that industry can and will be better, that we're at an inflection point, and that we're moving in a very positive direction regarding worker safety and operational productivity and waste elimination. And so what occurred to me and what led to this is really there's a series of people who are out there who have a lot of excellent information that they can share about what's actually happening that'll help us steer in the right direction. And that's what this is all about.
And so here we are today. You want to discuss how power or energy is generated, the power that fuels our manufacturing plants and our homes. And as I understand it, you have a very special guest to help us understand what's happening in this world. Why don't you introduce our guest for today?
Absolutely. And as I introduce our guest, just a quick word on why I asked this particular guest to be our first guest is in the context of the COVID crisis. One of the things that became clear is the discernment between essential and non-essential economic activity. And, when you look at what is the most essential part that makes our modern life, our modern society possible, it's a pretty strong argument that electricity is the most essential. Things break down pretty fast when you don't have it, and it powers our life, very literally. And even specifically within power, I look at nuclear as, most people that become educated about the energy industry quickly start to focus in on nuclear as sort of this unsolved puzzle of, how much of our future will it be? And that leads us directly to our guest. Lorne Poindexter is someone I've gotten to know through working together in his work at Ameren Corporation. Lorne is the senior manager of nuclear and fossil innovation. He's been there for 29 years and at the Callaway nuclear plant. And he's done jobs such as being a licensed reactor operator, a general supervisor of operations, maintenance manager, a whole series of roles over a 29-year career in the nuclear industry. And he's now very focused on innovation and continuous improvement to improve output and keep the rates as low as possible for the customer. So, Lorne, thank you very much for agreeing to join us today, and welcome.
Thank you, Jeremy, for having me. And that's a very good lead-in. One of our company's mission statement is to power the quality of life. So, very good.
Power the quality of life. I like that. I'd like to just start with you personally for a moment, if we could. What is it that brought you to the nuclear industry in the first place? What attracted you?
That's probably a longer story than we have time for, but I was just interested in learning. And when it comes down to it, you learn something new every day in the power industry. And as I progressed through my career, as I felt comfortable in one position, I thought it was time to learn something new and move to a different one. And that's kind of how I've progressed my career over the years.
And for those of us that aren't, the vast majority of people, including myself, have never worked in a nuclear power plant. What's it like? I mean, what do you love about working in a nuclear power generation station?
Well, the biggest difference you'll see between say a fossil plant or a gas plant and a nuclear plant is it's very, very clean. Um, you know, as in many other industries, we have very, very intelligent people and very smart people working side by side every day. Um, but the environment is so much cleaner because we don't have that coal dust or that extra uh, type of dirt and those type things in the plant. It's just kept very, very clean.
Yeah, I appreciate that. And it's interesting. When I was really thinking about this and thinking about who to initiate this industrial transformation interview series with, you bubbled to the top, and also nuclear. Just I think there's some facts. A lot of people don't study the facts of industry. And the reality is right now about 60% of America's electricity comes from fossil fuels. 38%, the majority is gas, natural gas. But nuclear is a lot. It's about 20%, and it's been a steady contributor for a long time. And one of the great things about nuclear is it's just zero emissions. There's some huge positive attributes. And is that so? When you describe clean, is that really what you're talking about? So compared to a gas or a coal-fired plant, you're getting the soot everywhere or smoke, or is that it, or is it beyond that?
Well, yeah, that's most of it. The emissions are very important, and as you mentioned, nuclear is zero emissions. We do have a small amount of radioactive waste that we have to deal with at times, and we have very good processes for dealing with that. So, yeah, the zero emissions is very important about nuclear, and since nuclear provides such a large base load for our grid, that's a good thing.
Yeah. I wonder if you could just describe it for us for a minute. It occurred to me in getting ready for this that a lot of people sort of have I don't know, a fear or a misunderstanding of nuclear power that that's sort of deep seated. But then, honestly, a lot of people's impression of the nuclear industry probably comes significantly from Homer Simpson. Just because that's what people are exposed to. I mean, what does it sound like when you're actually, what's the most interesting part of a nuclear reactor that you actually see, feel, hear when you're there?
Well, first of all, Homer Simpson is not a very good representation of nuclear power. uh,
I would imagine not, but why? Yeah.
Just to clear that up. So the the thing that's really neat about nuclear power, I mentioned how clean it is. When we do things, it's very, very large equipment. We're putting out 1,250 megawatts electric per hour, 24/7, and that's an incredible amount of base load electricity. Um, but we're coming up on a fall, and we have to refuel every 18 months, and we do that in the fall. So we have a refueling outage scheduled this fall. One of the biggest tasks and probably one of the neatest things that you could see in a nuclear power plant is the head removed from the reactor and disassembly of the reactor head so that we can get the old fuel out, put new fuel in. So that's a major activity. Safety is another big thing for us, Jeremy. Not only the public health and safety is the number one thing in nuclear power across the country, hands down. You will not see any different answer from anyone in nuclear power. Personnel safety is next, and we just everything we do is safe. It's well planned out, and there's documentation to support all the activities that are performed at a nuclear power plant.
Got it. Yeah, thanks, Lorne. I'm curious, what are the biggest challenges that you face? I know every industry that's looking at transforming is is facing manpower issues with trained workers, expert workers, and then also just general competitiveness, which in your case has a lot to do with operating cost, I think, and these new sources of renewables. What is it? What are the biggest challenges that affect the future of nuclear power?
Well, I've had this discussion with lots of people before, but it's cost. Basically, our industry, we have pursued safety and excellence over all these years to the point that we've driven our cost extremely high. And our fuel costs are very, very low as compared to a fossil plant. Maybe not quite as low as a gas plant right now today. And the operations and maintenance costs are really what drive our plants and our success. And you mentioned earlier the plants around the country. There's been a few plants that have closed because of costs. They couldn't efficiently produce that power.
So what are you doing about that? And it's a bit of a loaded question, obviously, because we've done some work together, our company and your plant. But how do you address that, the cost challenge?
Yeah, so we have started working on a project. All the chief nuclear officers got together a few years ago and made a decision that we would reduce our costs and by 30% over 5 years. So we're diligently working towards that. One of the initiatives, there's several initiatives to do that, but one of them is how we met. We're trying to more modernize our plant. And one thing that we've done at the Callaway nuclear plant is put in some wireless remote sensors that you're very familiar with to get to a condition-based maintenance program rather than time-based.
And how's that? What can you say about how that's working? Is it affecting your cost in a measurable way? Are you able to scale that?
So yeah, it has been very beneficial to Callaway. We've more than recouped our cost of the equipment and for the modernization of those with adding those sensors. We actually we're continuing to slowly add sensors at Callaway and improve our performance in that area. Last November, we implemented a thermal performance monitoring module. It's all wireless with pressure sensors and temperature sensors so we can remotely monitor our thermal performance. And the importance of that is that any lost thermal megawatts are taken away from electrical output megawatts. So that's a big savings when you can recoup those lost costs.
Because it just directly contributes to energy generated.
That's correct.
So, Jeremy,
yeah,
I could jump in, Jeremy, because you know what? Listening to this in terms of cost, I'm sitting here thinking, Jeremy, if it's okay, the question I'd like to ask is the talent. Like, who are the people that you're recruiting to operate these plants? Are these engineers, and where are they coming from? And is there a talent shortage for you?
That's a good question, Marty. We're all struggling in the nuclear industry as well as the utility industry in general with a retiring workforce and replacing them with a new generation or additional people to help with those tasks. It is a challenge. And, traditionally nuclear power, the workers came from a Navy background. That's not the case anymore. There's a lot of specialized educational programs around the country. There's some tech schools that offer nuclear training courses, operator training courses, radiation protection training courses. So we like to pull from everywhere. We do require highly intelligent people. So there's significant testing involved with working in a nuclear power plant. The other test you have to pass is the background check, and that's hard for some folks these days too.
Okay, thanks.
That is, it's a great question, Marty, because I know we see that everywhere. And incidentally, Lauren, strictly speaking, I'm one of those nearly qualified individuals. When I got my mechanical engineering degree from Penn State, the nuclear and mechanical engineering programs were merged at that time. So technically, I'm qualified, although the truth is I'm not. So it's good that you have the rigorous background checks. I'm curious if you would comment. When Marty and I talked for his interview, we talked about this particular, like the COVID crisis and all the extra challenges that's putting it on the workforce. Can you share any details about what you're experiencing in terms of having these workers able to go in and do their job?
Well, when you when you kick this off, Jeremy, you mentioned it. We feel that electrical power is essential, and it's something that you have to keep the lights on. You have to have people's devices working with all this work from home. So making power is essential for their country, and as a utility, we value that and accept that. So we've had to implement reduced manpower, reduced workforce, go down to minimum work activities, so that we have exposed our operating crews to less people. Um, Obviously, the most significant jobs we have on site are our operators. Our reactor operators and our non-licensed operators are essential to keeping the plant running. And you know, they're our top priority as far as making sure that they stay healthy and able to operate the plant. So yeah, we've had some challenges with that. We've implemented some self monitoring as well as checks on site, so that they can take the watch and do their jobs.
Hmm. Yeah, I mean, that's just something from KCF's point of view, just enabling those workers to do their work and to always be elevating it. And just, we really look at people as industrial heroes that make it. I think, you said you look at it as essential, but it is essential. When you look at what starts to happen when electricity is unavailable, society breaks down pretty fast. So I just say, on behalf of America, thank you for that, for keeping the lights on. So I want to
Well,
go one little bit further on that. Oh, go ahead. Go ahead.
we appreciate that, Jeremy. Thank you. I just want to thank you for that.
Oh yeah, no, absolutely. So taking Marty's question a little further, I look at it again because I know something about your operations. There's a couple different areas. There's the manpower issue that affect the future of nuclear and operating costs. I'm going to say there's maybe at least three big categories of that. There's the workers, the workforce, and then there are sort of the government and the organizations that regulate nuclear power industry. And then there's the organizations that are in place that can actually service the reactor, service the plant. Can you talk a little bit about the challenges of kind of operating within the cost constraints within any of those three factors?
Yes, our vendors are our support companies that help us refuel a reactor. For instance, we've got Westinghouse, Framatome, Areva, many companies that we engage with, and they do work for us at the plant. Those costs have incrementally increased over the last 20, 30 years. And, when we have to refuel, for instance, it takes a specialized crew to be able to safely handle that fuel and refuel our core. It takes a specialized crew to take the head apart and put it back together. And those safety precautions and those procedures are unbelievable. The measures that we go to for safety, but a big piece of that is hiring the right people to do those sub activities that we need done.
Okay. So if on the external part of it, the Westinghouse, I mean, I have lined up the next interview that we're doing is going to be with Jason Babick, who's the vice president of global strategy for Westinghouse. Is there anything you'd like me to ask him, or that as an organization, Ameren might ask Westinghouse to kind of make it easier for you to enable low cost operations?
Well, to the extent possible, if we can keep our costs down, would help, and that any help with that is appreciated. Recently we have evaluated a new fuel type, and which will enable us to either buy Westinghouse fuel or this other type fuel, and so there'll be some competition in the future on where we get our fuel even. So just introducing some competition will help as far as fuel costs go. And that's kind of happening across the industry. There's competition pretty much for every activity that Westinghouse does. So they'll probably have to react to that and make it easier for us, I would say, down the road.
Got it. Thanks. Hey, what about on the, so I know there's a couple of organizations that regulate the nuclear industry. And I wanted to come back, the thermal management that you were describing. I just wanted to give you and your whole team a big shout out. You won a big award, a very prestigious award from the Nuclear Energy Institute, the NEI, this year. Would you mind just sharing a bit about that award, and then also just broadly, like how that and EPRI interface with your operations to try to bring the cost down long term?
Well, thank you for bringing that up. That was a very prestigious award that our team at Callaway received. It's a top innovative practice award, TIP award from the Nuclear Energy Institute, as you stated. They give out a handful of those every year to different nuclear plants across the country that are doing something new and innovative or different. And I think they give those out when they see something that is significant to the industry and will change the way we do business. So the team that we had working on the wireless remote sensors, they planned it out, came up with, and we installed the thermal performance monitoring module. And when we addressed that with NEI, I actually met with them in Washington, D.C. to discuss, how the roadmap, how we got there. And they were really impressed with the way we went from back in 2017, starting to monitor rotating equipment in a pilot, to deploying a bunch of sensors on our secondary plant equipment, and then to a thermal performance monitoring module. And it fit right into one of the initiatives for reducing costs. So that was very significant. And I've also worked with EPRI, Electric Power Research Institute. EPRI had produced some quick guides, and myself and the STARS group, which is a strategic group of 4 single plant utilities or single nuclear plant utilities, that formed a group so that we can get discounts like the fleet plants do. And we worked with EPRI to produce some specific quick guides so that we could implement remote wireless monitoring in a cost-effective way and get to a condition-based maintenance plan. And we're well down the road working on that.
And has that now been done? Is that the EPRI approval of the ability for you to kind of expand that across, both within Ameren but to other companies? Has that now happened?
So those specific quick guides that we developed were for several of the STARS plants and Callaway. So we have Wolf Creek, Palo Verde Nuclear Facility, and Diablo Canyon as part of the STARS group. And any of those plants could take these specific quick guides now and implement them in a similar way that we did. And they are currently working on some pilots and things, but they haven't done a full deployment. We also, by doing that, we kind of set the stage for the industry so that they could start following down the path and implementing those quick guides as well. We did it all manually, manual evaluation, which, as you know, can be very strenuous at times and difficult. But now EPRI has also produced a computer program that helps evaluate those failure mechanisms and what you need to do as far as monitoring that equipment.
Are you now using some of those EPRI developed tools, or are you far enough along that you have essentially made your plan?
Well, since we did it manually, we're taking that documentation and moving forward. In the future, as we add different sets of specific equipment, we would run them through that computer program as they're available. As with anything in power and research and development, a lot of these things are always in flux and always being improved.
I see. That's great. Hey, I know we're almost going to be running out of time. When I look at industrial transformation of the entire energy sector and nuclear specifically, Lorne, I'm curious if you could comment on, if you take a 10-year outlook, what could power generation and specifically nuclear look like by 2030? And especially, you've talked with me before about the Gen 4 reactors. Can you just paint a picture for us as American citizens where could be headed?
Yeah, I think this is a personal opinion of Lorne Poindexter, but I think nuclear power is will be a significant factor in our future for energy. The Generation 4 reactors, like we've discussed in the past, are smaller. They're 250 megawatt plants. And they've got basically it's a submarine reactor instead of a industrial commercial reactor vessel that's harder to build. But other than size, they're very, very safe. All nuclear plants are very, very safe. However, these are intrinsically safe in the way that they're built, the way that they're designed. The other thing about that is they still provide that base load. Without a base load supporting our grid, with the way that solar and wind are coming into play, it makes it really hard for a utility company as a whole to manage that grid stability. With the times of day that people are going to be in the future possibly charging electric vehicles, for instance, there's places around the country today that have different rates at night. So people are drying their clothes at night from midnight to 6 in the morning because it's a cheaper rate. That's already going on today. But what that does when utilities offer those incentives, it's helping us balance the grid and balance the load so that we can keep the grid at an extremely stable position. The one other neat thing that we've talked about before, Jeremy, that I want to mention is, these Gen 4 reactors are designed around an improved fuel cycle or an improved way to use fuel. And we can actually, if the United States government would approve it, we can reprocess our spent fuel that we've used today from all the other reactors. We can reprocess that and remove the waste that the new reactors can't use. It would be a very small amount. And we can reuse that 90% of the energy that's still left in that spent fuel pool or that spent fuel. So by reprocessing it, it can be redesigned to work in the Gen 4 reactor. And we have enough spent fuel in this country today to power our country for 800 years without going and digging up and producing more fuel if we just reprocess what we have.
Yeah, that's just an amazing reality, Lorne. I appreciate you sharing that and just knowing that. I don't think there's very many people who are, really cognizant of that reality and how, and it's going to be important. It's going to be, making the right decisions is going to be such an important part of our future industrial landscape. And I appreciate you sharing that.
Yeah. And, I think around 2030 is when you'll see a lot of these small reactors come into play. As we start taking fossil plants off, most utilities have committed to being carbon free by 2050. So we're retiring fossil fuels, and the plain fact of it is, to get to carbon free, you can't have gas plants either, because they do have some emissions and a footprint in that area. So you have wind and solar, which, like I said, is hard to balance the grid with the times of day that's the most effective. So you still need that base load.
Yeah. And the way I look at it, it just paints a pretty rosy picture, but it kind of only if we're able to execute, over the next 10 years. And it's a thrill to be just teamed up with you and hear all the details with you. I think that it's time to wrap up, Lorne and Marty. I'd like to say thank you very much for spending the time this morning. And I would open the door either to Marty, or to Lorne maybe first. Is there anything else that's on your mind that you'd like to share?
The one thing that drives me every day, and it really drives our industry, is becoming more efficient and at producing our electricity. That continuous improvement that you mentioned, and our goal is to use innovation to keep our customer rates as low as possible. And when we can save those O&M costs, they get passed directly on to our customers in the form of rates. And if we can keep rates where they're at or near where they're at, and not have to raise our customer rates, that's our real goal. And to make that essential electricity to the home and the businesses, you have to have that, and it needs to be affordable for our customers.
Yeah. Well, thank you, Lorne. We just, I would say, as American citizens, we should and do appreciate the work that you and your teammates do. It's just really important stuff. So thank you.
Thank you for having me today, Jeremy.
Yeah. Thank you very much for being here again. And thanks, Marty, again for hosting this with me.
You bet. And my last comment would be, I think he said the power, the quality of life is what your phrase is that you said at the very beginning, Lorne. You did a great job of telling us more about that.
Thanks, Marty. I appreciate your support today, too.
Well, thank you very much to Lorne Poindexter from Ameren Corporation. We heard some really interesting stories today about the future of the nuclear power industry in America and what it can look like. It's a pretty bright future that's possible over 10 years, but only if Lorne and his teammates and people like them do the best they can to transform to a better future. So thank you very much for joining us. This is the Industrial Transformation Podcast, where we're telling stories from the front lines of American manufacturing.
Thanks for listening to the Industrial Transformation Podcast, a production of Business Builders Media. Learn more about how KCF can help you on your industrial transformation journey at kcftech.com, and check out more shows on businessbuildersmedia.com.